Alright, so in this video, I'm going to solve the equation 9 to the power of x plus 9 to the power of x plus 9 to the power of x is equal to 999. So to solve this, I'm going to first start by factoring out 9 to the power of x on my left-hand side. So I get 9 to the power of x times 1 plus 1 plus 1 is equal to 999. Now 1 plus 1 plus 1 is 3, so I get 9 to the power of x times 3 is equal to 999. From here, I'm going to divide both sides by 3. So these two cancel out, and I get 9 to the power of x is equal to 999 divided by 3, which is 333. Alright, so from here, I'm going to take the log on both sides. So I get log 9 to the power of x is equal to log 333. And if I have something in the form log a to the power of b, this is equal to b times log a. So log 9 to the power of x, I can move the x to the front. So I get x times log 9, which is equal to log 333. From here, I'm going to divide both sides by log 9 because we obviously want to isolate x. So these two cancel out, and I get x is equal to log of 333 over log 9. Now, I can rewrite log of 333 as log of 3 times 111. And I can rewrite log of 9 as log of 3 squared. Now, we know that if I have something in the form log a to the power of b, I can move b to the front. Another property of logarithms is that if I have something in the form log a times b, this is equal to log a plus log b. So I get x is equal to log 3 plus log 111 over 2 times log 3. And this is equal to log of 3 over 2 times log 3 plus log of 111 over 2 times log 3. So now these two cancel out, and I get x is equal to 1/2 plus log of 111 over 2 times 3, log 3. So now log of 111 is equal to 2.045. So I get x is equal to 1/2 plus 2.045 over 2 times log 3. And log 3 now is equal to 0.301. So I get x is equal to 1/2 plus 2.045 over 2 times 0.301, which is 0.602. So now log of 111, which is 2.05, divided by 0.602 is equal to 3.397, which is the same thing as 3.40. So if I add 1/2 to this, I get 3.90 as my solution. Alright, so in this video, I'm going to solve the equation x to the power of x is equal to x to the power of 2. So to solve this, I'm going to first start by dividing both sides by x to the power of 2. So then these two cancel out to get 1, and I get x to the power of x over x to the power of 2 is equal to 1. Now, I could use an important property of exponents that states that if I have something in the form a to the power of m minus a to the power of n, this is equal to, if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So in this case, I have x to the power of x over x to the power of 2, and it's going to equal x to the power of x minus 2 which is equal to 1. Now I'm going to take the ln, or natural log, on both sides. So I get ln x to the power of x minus 2 is equal to ln 1. Now, if I have something in the form ln a to the power of b, I can move this exponent b to the front, so this turns to b times ln a. So in this case, I can move x minus 2 to the front. So now I get x minus 2 times ln x is equal to ln 1. Now, if you didn't already know, ln 1 is actually equal to 0. So I get x minus 2 times ln x is equal to 0. And now I basically have two different equations. My first equation is x minus 2 equals 0. And my second equation is ln of x equals 0. So let's solve the first equation because it's the easiest. All I have to do is add 2 on both sides, and I get x is equal to 2. So this is one solution. And for ln x equals 0, to solve this, I'm going to take e to the power of both sides. So I get e to the power of ln x is equal to e to the power of 0. E and ln cancel out, so I get x is equal to e to the power of 0, which is 1. So my two solutions to this equation are x equals 2 and x equals 1. Now, if you haven't already, please make sure to subscribe, leave a like, and share this to any of your friends and family. Thank you.